Okay, good morning everyone. Now we're gonna continue into the next chapter, chapter 4, and we will begin with lesson 2. And the title for this chapter and lesson is the derivative of a product of two functions. You can open your book, page 132. Page 132. Okay. So on the previous chapter, you have learned that if you have a function that is an addition or subtraction of the other two functions, then actually the derivative of the function of fx, f prime x is actually the addition of the subtraction of each function being derived, right? So this is what you learned from the previous chapter. Now the question is, if a function is a product of two functions, a multiplication of two functions, does the derivative equal to the product of each function being derived? So that's the question for today's lesson. If fx equals gx times hx, is f prime x equal to g prime x times h prime x? To see this case, to see whether this property works or not, we will use the sample case. Let's say that fx is equal to x cubed times x power 4. Okay. So if we use this formula, if we use this property, then f prime x is actually equal to 3x squared times 4x cubed, which is equal to 12x power 5. Well, the truth is, actually fx we can simplify into x power 7, and the derivative of fx in this case is actually 7x power 6. So the property, if we use the property, the result is different with if we use the simplification, which is this one is, of course, this one is the correct one. So seeing this case, it's not true, one more time, it's not true that the derivative of a product of two functions is equal to the product of each function being derived. This is not true. You cannot use this. This cannot happen. Yeah. So then what's the correct way? What's the correct formula? So that's the objective of today's lesson. The objective is to find the formula of a product of two functions. Okay. Now, so what's the formula then? What's the formula? So let's say that fx is equals u times v, just to make it simpler and make it general. Yeah, u is a function, v is another function, then fx is a product of two functions. Okay. So, like I said, to find the formula of the derivative, you always use the mathematical definition of the derivative, right? Mathematical definition of derivative is always use fx plus h minus fx over h. This mathematical definition of derivative is always used as a source, as something that you use to find the formula of the derivative. Yeah, this is like your gut in your real life. When you have any problem, then you go to the source, which is gut. So like this, if you want to find the formula of the derivative, you go to this mathematical definition. Okay. So if I change it into u and v, then actually I can write it as limit of h approaching 0 of u x plus h times v x plus h minus u times v over h. Okay. Now let's stop for a while and let's see this graph. Okay. I have a random graph. Let's say that this is y. or let's just use u. Okay, so if I put a value of x here, then the value of the function here must be u of x, right? And if I make a distance for h here, so this will be x plus h, right? And this will be u of x plus h, right? And let's say that the distance between ux and u of x plus h is, we call it delta u. Delta u. Delta u. Okay. So basically, with this one, I can say that u of x plus h is actually equal to ux plus delta u, right? So for another function also, if I have phi of x plus h, then actually I can write it as phi of x plus delta phi. And let's remove the x here to make it the same with the original question, to the beginning question here. Okay. So in that case, if we take this one, then it's actually equal to the, I will move it down. So it's actually equal to the limit of h approaching 0. Ux plus h is equal to u plus delta u. Phi x plus h is equal to phi plus delta phi. That's all, minus u times phi over h. Okay, I hope you understand so far. Now let's continue. So after that, I'm gonna do the distributive, so it's equal to the limit of h approaching 0 of u phi plus u times delta phi plus delta u times phi plus delta u delta phi minus u times phi, okay, over h. Okay, so this is cancelled, and then I will separate it, so it becomes limit of h approaching 0 of u times delta phi over h plus delta u times phi over h plus delta u times delta phi over h. And limit properties from chapter 2, actually this can be separated into limit of h approaching 0 of u times delta phi over h plus limit of h approaching 0 of delta u of times phi over h plus limit as h approaching 0 of delta u times delta phi over h. Okay. Now the h is approaching 0. Now let's get back to this graph. When the h is approaching 0, actually the value of ux doesn't change, right? If the h is 1, the ux will not change. If the h is 2, the ux is not change. If the h is 0.5, the ux is not change. So it means that this is actually the value of u and the value of v does not depend on the value of the h. So it means that the u and the v here is not depending, is not affected by the value of the h. So it makes it can go to the front of the limit. So it becomes u times limit h approaching 0 of delta phi over h plus limit of h approaching 0 of, there is the phi, the front, I'm sorry, times phi times the limit of h approaching 0 of delta u over h plus limit of h approaching 0 of delta u times delta phi over h. Okay. Now realize that actually the limit of h approaching 0 of delta u over h is actually the instantaneous rate of change of u prime x, right? Because when the h is approaching 0, it means the delta u is also approaching 0. Isn't that the definition of the derivative, the slope of the tangent line, right? So actually, this and this, of this one and this one, actually can be written as u times phi prime, the derivative of phi. And this can be written as phi times u prime. Okay? And if we separate this, then we can write it as limit of h approaching 0 of delta u over h times limit of h approaching 0 of delta phi. So this will be u times phi prime, and I will switch it u prime phi plus, so this will be u prime times 0, right? So this is u prime and this is 0, because as the h is approaching 0, the phi is also approaching 0. As the h is approaching 0, the phi is also approaching 0. Okay. So I'll get the formula, I will rewrite it, that the derivative of a product is equal to u prime phi plus u phi prime. Okay. So conclusion, if fx is equal to u times phi, then f prime x is equal to u prime phi plus u phi prime. So this is the formula for today. Okay. Now let's see to the example, page 133. Example 1. If y equals x power 4 times cosine 6x, find dy dx, find the derivative. Okay, so let's say that this is u and this is phi. Okay, so if u equals to x power 4, u prime will be equal to 4x cubed, right? And if the phi is equal to cosine 6x, then phi prime is equal to negative 6 times sine 6x. Okay, so dy dx is equal to u prime phi plus u phi prime sine 6x. Okay, if we want to simplify, then it's equal to 4x cubed cosine 6x minus 6x power 4 sine 6x. Okay, and if you want to simplify, you can simplify it into factor out the GCF. The GCF is 2x cubed, so it's equal to 2 cosine 6x minus 3x sine 6x. Okay, you need to simplify if it's needed, if it's asked. Okay, now let's see example 2. Example 2, if y equals 3x minus 8 power 7 times 4x plus 9 power 5, then what's y prime? And simplify. Okay, so again, if u equals to 3x minus 8 power 7, then u prime is equal to 7, 3x minus 8 power 6. Don't forget to multiply with the derivative of inside function. Simplify. 21, 3x minus 8 power of 6. And if the phi is equal to 4x plus 9 power of 5, then phi prime is equal to 4x plus 9 power of 4 times 4, which is equal to 20 4x plus 9 power of 4. Okay, so in this case, y prime is equal to u prime phi plus u phi prime. Okay, u prime phi plus u phi prime, and then we find the common factor. The common factor is actually 4x plus 9 power of 4 with this one, and then also this one with this one. 21 and 20, it doesn't have the common factor. So if I factor out, then I will have 3x minus 8 power of 6, 4x plus 9 power of 4, and the leftover is, for the first term, the leftover is 21 times 4x plus 9. For the second one is 20 times 3x minus 8. Okay, so if I simplify, it's equal to 3x minus 8 power of 6, 4x plus 9 power of 4, and then I will multiply, it's 84x plus 189 plus 60x minus 240. Am I right? No, I'm sorry. It's supposed to be 160. 160. Okay. So it's equal to 3x minus 8 power of 6, 4x plus 9 power of 4, and then it's 144x plus 29. Am I right? Yes. So this is the answer. Okay. And let's see example 3. If y equals e power of sine x, find the 2y dx2. This is basically the second derivative, yeah. So the first derivative will be e power of sine x itself, right? Because it's e power of u, and then multiply by the derivative of inside function cos y, and then this will be your u and this will be your phi. So I will go directly. So y double prime is equal to u prime phi plus u phi prime. Okay. So this is u prime, this is phi, this is u, this is phi prime. Okay, if you get used to it already, then you may do that instead of writing it one by one like this. Okay, but you need to be careful, make sure that you are not careless. So if I simplify, then it's equal to e power of sine x times cosine square x minus e power of sine x times sine x. And then if I factor out e power of sine x, it's equal to cos square x minus sine x. Okay, so that's all for today. I hope that by this lesson, you're able to derive a product of two functions in a single step. Okay, thank you.